we're going to start with a triangle. Then we're going to pull 3 lines from the vertices of our triangle up until the opposite sides. They are passing through the single point, and as you can see, those lines are dividing our 3 sides of the triangle into 6 segments. Let's say that the bottom 2 segments have the length of 12 and 3, the 2 segments on the right have the length of 8 and 5, and let's say that the upper left segment has the length of 4. The question is, can we somehow calculate the area of the entire triangle? This problem was sent to me by my subscriber Julie. And if you guys want to try this one out for yourself, you can pause the video as always and then come back and check the solution. Alright, so let's solve this one together. And this is really an interesting one. I'm going to start by labeling all the vertices of our triangle as A, B, and C, and I will also label all 3 intersection points as D, E, and F. Now you can clearly see that we don't know the length of the segment AF, so let's try to calculate this segment first. In order to do this, we're going to use an awesome theorem which is called the Ceva's theorem. This theorem applies to any triangle and a Cevians. And if you're not familiar with the terminology, a Cevian is just a line segment connecting a vertex of a triangle to a point on the opposite side. And if we pull another 2 Cevians, which are concurrent, or in a plain terminology, this only means that they are passing through the single point, then we can use our Ceva's theorem. The Ceva's theorem states that if 3 lines drawn from the vertices of a triangle to the opposite sides meet at the single point, then the product of the ratios of those segments on each side is equal to 1. And if you want to use a more mathematical terminology, you can say that Ceva's theorem states that if 3 Cevians of a triangle are concurrent, then the product of 3 ratios of the divided sides is equal to 1. So you can use both of those explanations, whichever you like. And now we're just going to label the sketch on the right the same as sketch on the left. And if we use the same labeling and apply the Ceva's theorem, we will get the following formula, which we can use to find the segment FA. Alright, so let's do just that. Let's first implement the values of our segments from the sketch, and then we will do some small simplifications first. Then we're going to simplify this a little bit more and get that 10 over FA equals 1, which means that the length of the segment FA is 10, and we're going to implement this value into our sketch on the left. Alright, so now let's first calculate the sides of our triangle. We can do this easily as the side AB is just the sum of the segments AD and DB, which is 12 plus 3, and this side has the length of 15. And I'm going to substitute this side for small c. I'm going to do this because it's just going to simplify our calculations later. I'm going to do the same thing for the side BC. It consists out of segments BE and EC, which is 5 plus 8, and this is 13, and I'm labeling this side as small a, and finally the side AC, which is AF plus FC, or 10 plus 4, which is 14, and I'm going to label the side AC as B. Alright, so now we have all 3 sides of our triangle, and we need to find the area of the entire red triangle. This is actually quite simple if you know another formula, which is called the Heron's formula. This formula actually applies to any triangle, and if you know all 3 sides of the triangle, you can use the following Heron's formula to calculate its area. Now, if you're wondering what small s stands for, this is actually called a semi-perimeter, and it is calculated as the half of the sum of all sides of the triangle. Alright, so let's use those 2 formulas. First, let's use the formula of the semi-perimeter, and let's just implement our values of A, B, and C, and we can calculate and get that our semi-perimeter equals 21. Now, we can just take the values of a, b, c, and s and implement them into our Heron's formula. And if we do this, we will get the following. Now, we will just do some basic calculations and simplify to get the square root of 7056, which is actually a really nice number, and we will get that our wanted area is 84 squared units, and this is our solution. I hope you guys enjoyed this interesting and quick problem. If you did, do not hesitate to leave a like or subscribe to the channel for more content like this. If you found another way to solve this problem, write it down in the comment section below. And as always, see you guys in the next one, and take care.